Tonight, we are going to explore an idea that almost everyone has heard. An idea that sounds simple, familiar, even harmless, yet quietly dismantles the way our minds think about space, distance, and reality itself. The idea is called a light year. You have likely encountered this term many times before, perhaps in documentaries, news articles, science fiction stories, or casual conversations about the universe. It rolls off the tongue easily. A star is a few light years away. A galaxy is millions of light years distant. These phrases feel normal, almost mundane. And yet, hidden behind this familiar expression is one of the most disorienting concepts in all of science. Because a light year is not merely a large distance. It is a distance so vast that it strains the limits of human intuition, a measurement that quietly exposes how poorly our minds are equipped to understand the true scale of the cosmos. Most of the time, when we hear the term light year, we translate it in our heads as very far and move on. We rarely stop to ask what it actually means, what kind of distance it represents, or why astronomers needed to invent such a unit in the first place. But when you slow down and gently unpack the idea, something strange happens. The universe begins to feel different. Space no longer seems like a backdrop dotted with stars, but like an ocean of staggering emptiness where even light, the fastest thing that exists, must struggle patiently across unimaginable gaps. And once you begin to truly grasp that, even a little, it becomes impossible to see the night sky in the same way again. To understand why, we need to start with something deeply familiar: distance. Distance is one of the first concepts we learn as human beings. From a young age, we develop an intuitive sense of how far things are from us. We know the distance to the next room, to a nearby street, to a familiar store. We understand distance not as a number, but as an experience. Distance means effort. It means time. It means what we pass along the way. When someone tells you a place is 10 minutes away, you immediately imagine the walk or the drive. You picture intersections, buildings, maybe a stretch of road you have traveled many times before. This kind of distance feels solid and meaningful because it fits into the scale of human life. Even larger distances, like traveling between cities or across countries, still make sense to us. They take longer, require planning, but they remain imaginable. You can visualize the journey. You can picture the hours passing, the changing landscapes, the sense of movement from one place to another. These distances are woven into our bodies and our instincts. We evolved to navigate them. Our ancestors needed to know how far they could walk before nightfall, how long it would take to reach water, how distant a shelter might be. Our brains became very good at understanding distances that matter for survival on a single planet. But there's a quiet assumption hidden in all of this. The assumption that distance is something that can always be understood in human terms. That with enough time or effort, any distance can be crossed, measured, or imagined. This assumption works beautifully on Earth. It works reasonably well, even within our immediate cosmic neighborhood. But the moment we step beyond that, the moment we leave the comfortable scale of human experience, this assumption begins to break down. The universe does not care about what feels intuitive to us. It does not scale itself to human convenience. And this is where the idea of the light year enters the story. At first glance, the term itself is misleading. It sounds like time, a year, something familiar, something tied to seasons, calendars, and the slow rhythm of life. Many people naturally assume that a light year measures how long something lasts. But it does not. A light year is not a measure of time at all. It is a measure of distance. Specifically, it is the distance that light travels in 1 year. And already, without doing any calculations, this should give you pause. Because light is not just fast. Light is incomprehensibly fast. Nothing in our everyday experience prepares us for the speed at which light moves. When you flip a switch in a dark room, the room seems to brighten instantly. There is no sense of motion, no feeling of travel. The light simply appears. But this instant effect hides an important truth. The light did travel. It crossed the room, entered your eyes, and delivered information to your brain. It just did so at a speed so extreme that the delay is imperceptible. Our senses were never designed to notice such tiny intervals of time. Now imagine stretching that journey, not across a room, or a building, or a city, but across space itself. Imagine light leaving the surface of a distant star and beginning a long, silent voyage through darkness. No sound, no friction, no landmarks, just empty space, second after second, minute after minute, hour after hour. Light continues on its path, moving relentlessly forward at the same constant speed. It does not slow down. It does not speed up. It simply travels. When we say a star is 1 light year away, we are saying that the light you see tonight began its journey 1 year ago. It has been traveling, uninterrupted, for an entire year just to reach your eyes. And suddenly, distance and time become entangled in a way that feels unfamiliar. Because now, distance is no longer just about where something is. It is also about when you're seeing it. The light year forces us to confront a subtle but profound idea. The universe is not something we observe in real time. It is something we observe through layers of delay. The farther away an object is, the deeper into the past we are looking. Nearby stars appear almost as they are now. Distant galaxies appear as they were millions or even billions of years ago. The night sky becomes a kind of archive, a record of cosmic history written in light. And this is not a poetic metaphor. It is a physical reality. Every photon reaching your eyes tonight carries with it a timestamp from the past. The light year exists because other units simply fail at this scale. If astronomers tried to describe the universe using the distances we are comfortable with, the numbers would become so large that they would lose all meaning. They would turn into strings of digits that no human mind could intuitively grasp. A light year is not an attempt to complicate things. It is an attempt to simplify the incomprehensible. It compresses staggering distances into a form that allows comparison, that allows structure, that allows us to talk about the universe without drowning in zeros. But even this simplification comes at a cost. Because while the term makes cosmic distances easier to write down, it does not make them easier to feel. And that is where the quiet tension of the light year lives. It sits at the boundary between knowledge and intuition, between what we can calculate and what we can truly understand. Tonight, we are not here to rush through equations or overwhelm ourselves with numbers. We are here to slowly build a sense of scale, to move gently from what feels familiar to what feels strange, to allow our minds to stretch, not to the point of strain, but to the point of wonder. Because the goal is not to master the concept of a light year in a technical sense. The goal is to let it change the way the universe feels. To realize that space is not just big, but profoundly, almost unfathomably vast. That the stars are not just distant objects, but ancient messengers. And that every time you look up at the night sky, you are participating in a quiet conversation between the present and the deep past, carried across unimaginable distances by the steady, patient motion of light. To begin understanding distances that stretch far beyond anything we have ever traveled, we need to stay grounded a little longer in the world our minds were built for. Before space becomes abstract and scale begins to dissolve, it helps to linger with the distances that feel natural to us, the ones that quietly shape our daily lives without ever demanding conscious thought. Distance for a human being is not a number. It is a sensation. It is measured in footsteps, in minutes, in the slow rhythm of effort and rest. You do not usually think about how many meters separate you from your destination. You think about how long it will take, how tired you might feel, what you will pass along the way. A nearby place feels close, not because it is objectively small, but because it fits easily into the structure of your day. You know how far you can walk before your legs begin to ache, how long you can focus before your attention drifts, how much time you have before night falls. These internal measures are older than mathematics. They are written into our nervous systems by millions of years of survival on a single planet. When someone tells you a store is a few minutes away, your body understands that information instantly. You imagine the walk, the familiar streets, the small transitions that mark progress. When a place is farther, perhaps an hour away, the feeling changes. You begin to plan. You think about transportation, about time set aside, about the subtle shift in commitment required to leave and return. Distance becomes tied to intention. Longer journeys demand preparation, and preparation gives distance its weight. Even when distances grow larger, crossing cities or countries, they remain within a framework your mind can still hold. A long drive, a train ride, a flight across a continent. These journeys compress distance into manageable experiences. You sit, you wait, you watch landscapes slide past windows. Hours pass, meals are eaten, sleep happens. The distance is large, but it is still human. It unfolds at a pace that matches the tempo of a human life. Even the size of the Earth itself, immense as it is, does not fully escape this framework. The idea that you could, in theory, travel all the way around the planet does not feel impossible. It feels ambitious, perhaps exhausting, but conceivable. People have done it. Ships have sailed around the globe. Aircraft have traced its curvature through the sky. The Earth is vast, yet bounded. It is something that can be circled, mapped, explored, at least in principle. This sense of containment is crucial. It allows the mind to relax. The Earth may be large, but it is not infinite. It fits, however imperfectly, into the mental models we use to navigate our lives. But notice what all of these distances have in common. They are defined not just by space, but by experience. They are distances you can move through. Distances that allow for interaction. Distances where the journey itself has texture. Roads, oceans, skies, landmarks, and changes. The mind relies on these features to make sense of scale. Without them, distance begins to lose its meaning. This is why, when we talk about the Earth as a whole, we still rely on metaphors of travel. We imagine lines drawn across maps. We imagine paths, routes, circumnavigations. Even space agencies describe planetary distances in terms of travel time, because time is something we feel. Time gives distance a narrative, but as we prepare to move beyond Earth, something subtle begins to shift. The distances stop offering us stories. The terrain disappears. There are no roads in space, no landscapes unfolding beneath your feet, no gradual transitions from one environment to another. There is only emptiness, broken occasionally by islands of matter suspended in darkness. And this is where the familiar language of distance begins to fail. The Earth, from the surface, feels enormous. Mountains stretch into the sky. Oceans seem endless. Horizons curve gently away. But from a little farther out, from a perspective we rarely experience, the Earth becomes surprisingly small. It shrinks from a world into an object, a sphere, a fragile layer of air wrapped around rock and water. This change in perspective is not just visual, it is conceptual. When astronauts first looked back at Earth from space, many of them described a profound emotional shift. The planet they had known as an endless environment suddenly appeared finite, contained, and delicate. The distances that once felt vast were revealed to be thin slices on a small globe. This is an important moment in our journey because it marks the boundary between intuitive distance and cosmic distance. As long as we remain on Earth, distance feels personal. It is measured in effort and time. Once we step away from it, distance becomes impersonal. It becomes geometry. The gap between Earth and the Moon is often the first place where this transition becomes noticeable. The Moon feels close. You can see it clearly with your own eyes. Its surface features are visible through modest instruments. It hangs in the sky night after night, familiar and comforting. And yet, the space between Earth and the Moon is already vast in a way that resists intuition. There is nothing in that gap. No air, no landmarks, no sense of movement unless you are traveling at extraordinary speed. The distance is pure separation. It exists not as a path, but as an absence. The mind struggles with this kind of distance because it offers no feedback. On Earth, you know you're making progress because the environment changes around you. In space, progress is invisible. You could travel for hours or days, and the view would remain almost exactly the same. Darkness, punctuated by distant points of light. This emptiness is not just physical, it is cognitive. The brain searches for reference points and finds none. And yet, even this distance, Earth to Moon, is still close by cosmic standards. It is part of Earth's immediate neighborhood. It is a distance we have crossed. The journey took days, not years. It demanded technology and precision, but it remained within the bounds of a human lifetime. This is an important psychological threshold. As long as a distance can be crossed within a lifetime, the mind retains a sense of possibility. It can imagine departure and return. It can imagine cause and effect unfolding in familiar ways. But as distances grow larger, even this fragile sense of connection begins to erode. The Earth orbits the Sun at a distance that already pushes the limits of intuition. The Sun feels near. It dominates our sky. It warms our skin. It shapes our days and seasons. It feels like a constant presence, and yet the space between Earth and the Sun is so large that even light, moving at its extraordinary speed, takes minutes to cross it. Minutes may not sound like much, but they represent a profound shift in scale. This is no longer a distance where cause and effect feel immediate. It is a distance where delay becomes real, where events happen and their consequences arrive later. The Sun you see is not the Sun as it is now, but as it was moments ago. This realization is gentle at first. 8 minutes does not feel like a long time, but it introduces a pattern that will repeat again and again as we move outward. Distance is not just about space, it is about waiting. It is about the separation between an event and your awareness of it. And this separation grows relentlessly as distances increase. What makes the Earth such a powerful reference point is that it anchors us to a scale where waiting is minimal. Communication is nearly instantaneous. Travel, while sometimes slow, unfolds within a narrative we can grasp. The planet provides a closed system where distances feel meaningful and manageable. Leaving that system, even conceptually, begins to loosen the grip of intuition. The familiar measures of kilometers and miles start to feel inadequate, not because they are wrong, but because they no longer connect to experience. Sayings that the Earth is a certain number of kilometers from the Sun does not evoke a journey you can imagine. It does not evoke effort, fatigue, or anticipation. It becomes a sterile statement. And this is precisely the moment when astronomy begins to change its language, not to confuse us, but to cope with a reality that no longer fits human instincts. The light year emerges from this breakdown. It is born from the realization that space does not behave like Earth, that distances in the cosmos are not meant to be crossed easily, or perhaps at all, that the universe is structured in such a way that separation is the rule, not the exception. Before we fully embrace that idea, however, it is worth appreciating just how special our familiar distances are. Life evolved in a narrow band of scales, too small, and the world dissolves into atoms and forces. Too large, and it dissolves into emptiness and silence. The distances of daily life sit in a delicate balance where movement matters, where perception and action are tightly coupled. This balance gives rise to meaning. It allows us to care about where things are, because where things are determines what we can reach, influence, or experience. As we prepare to move beyond Earth, it is important to recognize that this balance does not persist. The universe is not scaled for us. It does not privilege our senses or our timelines. The distances between worlds are not obstacles waiting to be overcome. They are features of reality itself. They define how information flows, how causality unfolds, how isolation and connection are distributed across space. Understanding this begins not with numbers, but with contrast. By holding on to the familiar for a little while longer, by acknowledging how deeply our sense of distance is tied to life on Earth, we give ourselves a stable foundation from which to let that sense slowly unravel. Because what comes next will not simply be bigger distances. It will be a different kind of distance altogether. One that does not ask how far something is, but how long light must travel before we can even know it exists. As we move outward from the familiar scales of daily life and the comforting boundaries of Earth, the solar system becomes the first place where our ordinary understanding of distance begins to quietly collapse. In Part 2, we lingered with distances that still made sense because they could be experienced, traveled, or at least imagined through effort and time. The Earth, even in its vastness, remained a world we could circle, map, and conceptually hold. But the solar system is different. It is not an extension of Earth's landscape. It is a realm where space itself becomes the dominant feature, where emptiness overwhelms matter, and where the units we rely on to make sense of distance start to feel strangely hollow. At first, the transition is subtle. The moon still feels close, familiar, almost reachable. It is visible to the naked eye, detailed enough to feel tangible. And yet, even here, something has already changed. The space between Earth and the Moon contains nothing. No air, no gradual terrain, no markers of progress. Just an uninterrupted stretch of vacuum. Crossing it requires sustained speed and precise calculation. There is no sense of movement unless you already understand the physics involved. This absence is important because it introduces a new kind of distance, one that does not reveal itself through experience. You do not feel how far away the moon is by looking at it. Your intuition, shaped by life on Earth, cannot grasp the separation. It simply looks nearby. And yet, the time required to cross that gap tells a very different story. Days pass. Motion happens, but nothing changes visually. Darkness remains darkness. The moon does not grow gradually larger in a satisfying way. It simply remains distant until suddenly it is not. This is the first hint that distance in space behaves differently. It is not meant to be felt. It is meant to be endured. When we shift our attention from the moon to the sun, the familiar sense of scale breaks even further. The sun feels close. It dominates our sky. It defines our days, our seasons, the rhythms of life itself. It feels like a presence, something almost immediate. But this feeling is deeply misleading. The space between Earth and the sun is vast beyond anything we encounter on our planet. It is a distance so large that even expressing it in kilometers begins to feel artificial. The number exists, but it does not connect to anything we have lived. You cannot imagine walking it. You cannot imagine driving it. You cannot even meaningfully imagine flying it. There is no experiential anchor. The mind reaches for comparison and finds none. This is where kilometers begin to lose their power. Not because they are inaccurate, but because they no longer translate into intuition. A kilometer on Earth is something you can feel in your legs. A kilometer in space is just a concept. Multiply that kilometer by millions, and it becomes a symbol rather than a sensation. The solar system exposes this limitation relentlessly. The planets are not arranged like stepping stones. They are separated by enormous gulfs of empty space. Even the inner planets, which we tend to think of as relatively close together, are divided by distances that overwhelm human scales. The space between Earth and its nearest planetary neighbors is not a void you casually cross. It is an expanse that resists traversal, even with our most advanced technology. And yet, from the perspective of the solar system as a whole, these inner planets are clustered tightly around the sun. This contrast is crucial. Distances that feel impossibly large to us are still tiny compared to what lies farther out. The solar system stretches our intuition in both directions at once. It makes nearby things feel far and distant things feel unreachable. As we look outward, the pace at which distances grow begins to accelerate. Mars, Jupiter, Saturn, and beyond are not just farther away in a linear sense. They are separated by increasing intervals of emptiness. Each step outward adds not just space, but delay. Signals take longer to arrive. Commands must be planned in advance. Cause and effect drift apart in time. This delay is not a technical inconvenience. It is a fundamental feature of space. It is the universe reminding us that separation has consequences. When you send a message across the solar system, you are not communicating in real time. You're sending information into the future, hoping that when it arrives, the situation will still be relevant. This simple fact reshapes everything from exploration to control. You cannot react instantly. You must anticipate. You must accept uncertainty. The solar system teaches us patience, not as a virtue, but as a requirement imposed by distance. As spacecraft travel farther from Earth, this requirement becomes more pronounced. The outer planets are not just far away. They are distant in a way that disconnects them from immediate human influence. A spacecraft operating near these worlds must function independently, making decisions without waiting for human input. By the time a problem is noticed on Earth, hours may have passed. The situation may have changed completely. This autonomy is not a design choice. It is a necessity forced by the scale of space. And still, all of this remains within the solar system, a region that is, on cosmic scales, astonishingly small. This realization is deeply unsettling. If the solar system already pushes our units to the breaking point, what hope do they have beyond it? Kilometers begin to feel like counting grains of sand to measure the size of an ocean. The numbers grow, but understanding does not. The solar system also reveals another important truth. Most of space is not filled with things. It is filled with nothing. The planets, moons, asteroids, and comets that capture our attention are exceptions, not the rule. They are tiny islands of matter adrift in a sea of emptiness. When we imagine the solar system, we often picture diagrams where planets are neatly arranged, evenly spaced, and visually prominent. These images are useful for teaching, but they distort reality. In truth, if you could shrink the solar system down to a manageable size and walk through it, you would spend almost all of your time walking through empty space. The planets would be rare interruptions, brief encounters separated by vast monotonous stretches of nothing at all. This emptiness is not dramatic. It is not violent. It is quiet, stable, and persistent. It does not announce itself. It simply exists. And this is why the solar system is such an important psychological threshold. It is the first environment where emptiness dominates structure. On Earth, emptiness is rare. We fill space with air, sound, life, and activity. In the solar system, emptiness is the default state. Matter is the exception. Distance, in this context, is not about how far you must travel between interesting places. It is about how long you must persist in the absence of anything changing. This kind of distance is deeply alien to the human mind. Our instincts are tuned to environments where feedback is constant. We move, and something happens. We act, and the world responds. In the solar system, you can move for days, weeks, or months, and nothing responds. The stars remain fixed. The darkness remains unchanged. This is where kilometers finally give up their last connection to intuition. 1 million kilometers of empty space feels no different from 10 million. The experience is the same. Only time distinguishes them. And this is the quiet pivot point. Distance becomes time, not metaphorically, but practically. How long does it take light to cross this gap? How long does it take a signal to arrive? How long must a spacecraft travel before anything changes? These questions replace the question of how far. The solar system teaches us that distance is not something we overcome by adding effort. It is something we endure by waiting. And waiting introduces a new dimension of meaning. When waiting times are short, they feel trivial. When they stretch into minutes, hours, and days, they begin to shape behavior. When they stretch into months and years, they reshape entire systems. Planning replaces reaction. Prediction replaces control. The farther we move from Earth, the more the universe insists on this shift. The solar system is the last place where kilometers still appear in casual conversation. Beyond it, they become unwieldy. They grow too large to be useful. they lose their descriptive power. They tell us nothing about what it feels like to exist across such separations. This is not a failure of mathematics. It is a revelation about scale. The universe is not obligated to make sense to us. It is not obligated to align with the units we invented to measure fields and roads. The solar system stands as a kind of warning. It shows us that even before we reach the stars, our familiar tools are already failing. That the gap between worlds is not just physical, but cognitive. And yet, there is something strangely calming about this realization. As distances grow and intuition fades, the universe becomes less demanding. It stops asking us to imagine crossing every gap. It stops inviting us to picture journeys we cannot take. Instead, it invites us to observe, to accept that some distances exist not to be traveled, but to define separation itself. The solar system, in all its quiet vastness, is the place where we first encounter this idea in full. It is where kilometers begin to lose their meaning, and where a new way of thinking about distance begins to take shape. A way that does not ask how far something is in human terms, but how long light must travel before we can even know it is there. As the solar system quietly teaches us that kilometers no longer anchor meaning, we are led naturally to the one thing that does remain consistent, reliable, and absolute across all of space. When distance turns into waiting, when emptiness dominates experience, and when separation begins to feel less like a path and more like a condition, everything converges on a single question. If space is defined by delay, then what sets the pace of that delay? The answer is light. Not as illumination, not as brightness or color, but as motion, as the fastest way anything can happen, as the universal messenger that connects events to awareness. In Part 3, distance began to collapse into time. Here, the transformation completes itself. Because once we follow distance far enough, we are no longer really talking about space at all. We are talking about the speed of light. Light is not merely fast, it is different in kind from every other motion we know. Cars move quickly compared to walking. Aircraft move quickly compared to cars. Spacecraft move quickly compared to anything built on Earth. But all of these speeds exist on the same ladder. They differ by degree, not by nature. Light does not sit on that ladder. It stands apart from it. Nothing accelerates to light the way it accelerates to other speeds. Nothing catches up to it. Nothing overtakes it. Light does not compete. It defines the upper limit of how fast anything can influence anything else. This is not a technological limitation. It is not a challenge waiting for better engines. It is woven into the structure of reality itself. And this is why, when we talk about vast distances, we inevitably stop measuring how far something is and begin measuring how long light takes to cross the gap. The moment you adopt this perspective, the universe subtly changes character. Space stops feeling like an arena filled with objects and starts feeling like a delay network. A place where events happen, but awareness arrives later. On Earth, we live in a world where this delay is almost non-existent. Light crosses rooms, buildings, even cities so quickly that the time it takes is invisible to us. Our nervous systems evolved under the assumption that seeing is immediate. We open our eyes and the world is there. This assumption works perfectly well at human scales, but it is an illusion maintained by small distances. The solar system dismantles that illusion gently. The speed of light remains the same, but the distances grow large enough for the delay to reveal itself. The sun, you see, is already in the past. Not long ago, not meaningfully different, but past nonetheless. This is the first crack in the idea of a shared present. Once you notice it, it cannot be unseen. Light is not instantaneous. It has a finite speed. And finite speed means that simultaneity, the idea that events everywhere are happening at the same now, begins to dissolve. The speed of light becomes the rhythm of causality. It determines how quickly information can propagate. It defines the boundary between what can influence you and what cannot, at least not yet. And because light travels at the same speed everywhere, regardless of where it is or who is observing it, it becomes the closest thing the universe has to a universal constant. Everything else depends on context. Motion depends on reference frames. Time depends on speed and gravity. Distance depends on perspective. But light remains stubbornly the same. It does not adapt to us. We must adapt to it. This is why the light year exists, not as a clever invention, but as a necessity. When astronomers began to confront distances beyond the solar system, they faced a problem that could not be solved by larger numbers alone. Kilometers multiplied endlessly, but intuition vanished. More importantly, kilometers failed to capture what mattered most. They told you how much space lay between objects, but not how separated those objects truly were in terms of interaction. Two places separated by millions of kilometers might still feel close if light crosses that distance quickly. Two places separated by a few light years are profoundly isolated, not because of the number, but because of the weighting. The light year compresses distance and delay into a single concept. It answers not just where something is, but when you're seeing it. To say something is 1 light year away is to say that the universe has imposed a 1-year silence between cause and awareness. Events happen there, but you will not know about them until time has passed. This is a different way of thinking about separation. It is less spatial and more temporal. It reframes distance as patience. The nature of the light year becomes clearer when we abandon the urge to calculate and instead focus on experience. Imagine light leaving an object, any object, and beginning its journey. It does not know its destination. It does not carry intention. It simply moves, endlessly, at the same speed, through whatever space exists ahead of it. If the object is nearby, the journey is short. If the object is far away, the journey is long. But from the light's perspective, nothing changes. It always moves as it must. The universe, however, is structured so that these journeys can last minutes, years, centuries, or longer. When we use light years, we are aligning our measurements with this reality. We are choosing a unit that respects the way the universe actually transmits information. In the solar system, light minutes and light hours already begin to feel more meaningful than kilometers. They tell us something about responsiveness, about delay, about how connected or disconnected two places are. As we move beyond the solar system, kilometers become increasingly irrelevant. They can still be written down, still be calculated, but they lose explanatory power. A light year, by contrast, immediately communicates scale in a way that matters. It tells you that whatever is happening, there is happening outside your present. You're always late. This idea is quietly unsettling. It suggests that the universe does not offer a single shared moment. Instead, it offers countless local presents, each confined to its own region of space, each unaware of the others until light bridges the gap. The night sky becomes a mosaic of different times. nearby stars shine almost as they are. Distant galaxies shine as they once were. Some may no longer exist in the form we see. Their light continues, indifferent to the changes that occurred after it departed. The speed of light makes ghosts unavoidable. Images of things that have changed or vanished still arrive, still inform our instruments, still shape our understanding. The light year does not just measure distance, it measures how outdated your view of the universe is allowed to be. This realization deepens as we consider how absolute the speed of light truly is. Nothing outruns it. Nothing shortcuts around it. Even gravity, which shapes the motion of galaxies and the structure of the cosmos, propagates at the same speed. This universality creates a kind of cosmic speed limit. It does not matter how much energy you apply. As you approach the speed of light, the rules change. Time slows. Distances contract. Effort increases without bound. The universe resists. This resistance is not mechanical, it is geometric. Space and time adjust themselves to preserve the speed of light as an invariant. The consequences of this are profound, but they all point back to the same conclusion. Light is not just something that moves through space. It defines how space and time relate to each other. A light year, then, is not an arbitrary choice. It is a unit that acknowledges this deep relationship. It ties distance directly to the structure of space-time. It tells us that to talk about separation without talking about light is to miss the point entirely. When we say the solar system is small on cosmic scales, we are really saying that light does not have to work very hard to connect its parts. Signals arrive quickly. Feedback loops remain intact. Cause and effect feel continuous. Beyond that, everything stretches. Communication slows. Influence weakens. The universe becomes compartmentalized. Regions drift into isolation, not because space is hostile, but because light takes too long to cross the gap. The light year captures this isolation elegantly. It is a unit born from humility. It admits that our intuitive measures no longer apply. It accepts that the universe operates on scales indifferent to human convenience, and it invites us to think differently, to stop imagining journeys and start imagining delays. This shift prepares us for what lies beyond. Because once we accept that distance is measured in years of waiting, the stars stop feeling like destinations and start feeling like stories arriving late. The speed of light ensures that the universe is always slightly out of sync with itself. There is no universal now. There is only a vast network of delayed awareness stitched together by photons moving steadily through darkness. In this context, the light year becomes less a measurement and more a perspective. It reminds us that the universe we observe is not the universe as it is, but the universe as it was, filtered through the finite speed of light. This perspective does not diminish reality. It deepens it. It tells us that every observation is an encounter with history, that every distant object carries with it a built-in delay, a reminder that separation is fundamental. And as we prepare to move beyond the solar system, beyond even nearby stars, this understanding becomes essential. Because the farther we look, the more the universe reveals itself not as a place of immediate presence, but as a vast archive, where distance is written in years, and light is the patient courier connecting what was to what is known. Once the speed of light becomes the framework through which distance makes sense, the universe begins to reveal itself in a new, quieter hierarchy. In Part 4, Distance transformed fully into delay, and the light year emerged not as a convenience, but as an honest description of separation. Now, instead of thinking in terms of how far something is, we begin thinking in terms of how long light must travel before information can arrive. To make this shift gentle rather than overwhelming, it helps to move step by step, building from the smallest meaningful unit upward. The universe does not leap from seconds to years without passing through every scale in between, and neither should our understanding. The smallest unit that begins to carry meaning beyond the abstract is the light second. A single light second is the distance light travels in 1 second. That sentence alone sounds technical, almost trivial, but its implications are already startling. In 1 second, light moves far enough to circle the Earth multiple times. It crosses distances that would take aircraft many hours to traverse. And yet, from the perspective of human perception, a second is fleeting. It slips by unnoticed. When you blink, more than a light second has passed. This contrast is the first quiet fracture between intuition and reality. A single second feels small, almost empty. A light second is vast. Already, time and space have slipped out of alignment. Within a light second lies the distance between Earth and the Moon, and most of the way back again. This means that when astronauts spoke from the lunar surface, their voices did not arrive instantly. Every word waited. Every reply waited in return. Conversation itself became stretched, not by technology, but by physics. Even at this smallest cosmic scale, the universe refuses immediacy. It insists on delay. Moving outward, 60 light seconds become a light minute. This is where the scale begins to feel unmistakably alien. A light minute is the distance light travels in 1 minute, a span of time you barely register while waiting for a web page to load or glancing at a clock. And yet, in that minute, light has crossed millions of kilometers. This is no longer a distance tied to any human journey. It is pure separation, bridged only by speed. The sun, our constant companion in the sky, resides several light minutes away. This means that the warmth you feel on your skin is already old. The light bathing the Earth began its journey before you became aware of it. If something were to change at the sun, that change would not be known immediately. The universe would continue presenting an outdated version of reality for minutes at a time. This delay is small enough to feel insignificant, but large enough to reveal a pattern. Events and awareness are no longer synchronized. They are staggered. As we continue outward, the light hour emerges. 60 light minutes combine into a span that already dwarfs anything we instinctively understand. A light hour stretches across distances so large that entire planetary systems fit comfortably within it. From Earth, some of the outer planets reside light hours away. This means that spacecraft operating there exist in a different temporal bubble. Commands sent from Earth arrive long after they are issued. Responses return even later. The concept of real-time control dissolves. Decision-making shifts from reaction to prediction. The universe begins to demand foresight, not because it is cruel, but because light takes time. The light hour marks a psychological transition. It is the scale at which patience stops being optional and becomes structural. Beyond this, we reach the light day. 24 light hours woven together into a distance so immense that even our fastest machines feel motionless by comparison. A light day is the distance light travels in one full rotation of Earth. It is a unit that quietly contains the entire human rhythm of waking and sleeping. And yet, in cosmic terms, it barely scratches the surface. Some of our farthest spacecraft now operate at distances measured in light days. When we speak to them, we are speaking into the past and waiting for the future to respond. A full day passes before acknowledgement returns. The gap between action and consequence stretches until it feels abstract. The light day teaches us something subtle but important. Distance does not merely separate locations, it separates moments. The farther out we go, the more the present fractures into layers. Next comes the light week. 7 light days combined into a span that feels almost fictional when expressed in ordinary language. A light week reaches far beyond the last planets, into regions where the sun is no longer a dominating presence. At this distance, our star shrinks into just another point of light among many. The solar system begins to lose its coherence as a system and starts to resemble a loose association of objects bound weakly by gravity across vast emptiness. The light week is the scale at which our immediate cosmic neighborhood dissolves. The sun's influence fades, its warmth becomes negligible, its authority over space diminishes. What remains is a sense of isolation that feels absolute. The light month follows naturally. Roughly 30 light days, carrying light across distances so large that even the concept of a system feels strained. At a light month, the solar system compresses into insignificance. The planets become points clustered around a single star that no longer dominates the sky. The environment here is not merely empty, it is indifferent. Light travels faithfully, but nothing else offers connection. The light month strips away any remaining illusion that space is meant to be crossed. It presents distance as an intrinsic feature, not a challenge. And then, finally, the light year. 365 light days. A span that feels deceptively modest in language and utterly overwhelming in reality. The light year is not just larger than the units before it. It is categorically different. It marks the boundary between local and stellar. Within a light year, stars remain distinct entities, separated by gulfs so large that even light requires years to traverse them. The light year is where cosmic isolation becomes undeniable. A star 1 light year away exists in a different temporal neighborhood. Everything you see from it is already history. If it changes, if it dims or brightens or dies, you will not know for a year. And this delay is the smallest possible delay between stars. Most are farther, much farther. What makes this progression from second to year so powerful is not the growth in numbers, but the erosion of immediacy. At every step, something familiar is lost. First, instant feedback, then conversational rhythm, then control, then presence itself. By the time we reach the light year, the idea of sharing a moment across space has vanished entirely. There is no simultaneity. There is no shared now. There are only overlapping pasts arriving at different times. This ladder of light units reveals the true structure of the universe. It is not arranged around human experience. It is arranged around causality, around how long information takes to move. The universe does not ask whether a distance feels large. It only cares whether light has arrived yet. These units also reveal something quietly humbling. The solar system, which felt vast and overwhelming in Part 3, collapses into a tiny cluster when measured in light years. All of human history, all of our exploration, all of our machines exist within a fraction of a light year from our star. Even our farthest probes have barely stepped beyond a single light day. the gulf between what we can reach and what exists is not just large, it is foundational. The light year does not exaggerate this gulf. It names it honestly. It tells us that the universe is sparse by design. Stars are not neighbors in any meaningful sense. They are isolated islands, each surrounded by oceans of darkness measured not in kilometers, but in years of waiting. And this waiting is not passive. It shapes everything. It defines what can be known, when it can be known, and whether it can ever be known at all. As we climb this scale from seconds to years, something else becomes clear. The universe does not rush. Light moves as fast as it can, and still it is not fast enough to erase separation. This is not a failure. It is a feature. It ensures that the universe is layered, that history persists, that events leave echoes that take time to arrive. The light year is simply the point at which this truth becomes impossible to ignore. It is the unit that tells us we are not seeing the universe as it is, but as it was, and that the farther we look, the older the stories become. This understanding prepares us for what comes next, because once light years become the language of distance, the stars stop being destinations and start being messages. Messages that have been traveling for years, centuries, or longer, crossing emptiness without regard for whether anyone is listening. And as we continue outward, beyond individual stars, the scale will stretch even further until light years themselves begin to feel small, and the universe reveals just how deeply it is structured around time, patience, and the quiet, unstoppable motion of light. As the ladder of light units stretches from seconds to years, a quiet realization settles in. Distance has fully transformed into time. By the end of Part 5, the light year no longer feels like an abstract definition, but like a threshold, a boundary beyond which separation becomes absolute. Now, as we turn our attention to the stars nearest to us, that realization deepens into something more personal and more unsettling. Because when distance is measured in years of waiting, looking outward is no longer just an act of observation. It becomes an act of time travel, not forward, but backward. To look at a star is to look at the past, and the farther that star is, the deeper into the past you are forced to see. The stars closest to the sun are still unimaginably far by human standards, yet they represent the smallest possible step beyond our own stellar island. They are the universe's nearest neighbors, though the word neighbor barely applies. Even these closest stars are separated from us by light years of darkness, silence, and delay. When you look at them, you are not seeing what is happening there now. You're seeing what happened years ago, sometimes before moments in your own life that feel recent. This is not metaphor. It is not poetic exaggeration. It is the unavoidable consequence of the finite speed of light. The universe does not allow information to arrive instantly, no matter how close a star feels in the sky. The nearest stars appear bright and steady, almost comforting. They do not flicker dramatically. They do not seem remote. They are simply there, night after night, fixed against the background of the sky. This stability creates an illusion of presence. It feels as though we are sharing the same moment with them, but we are not. Even the closest stars exist in a different temporal bubble. Their light began its journey long before it reached your eyes. Every photon you receive tonight left its source years ago, carrying an image of a star as it once was, not as it is now. This is the first profound shift that near stars introduce. They force us to abandon the idea of a universal present. On Earth, we take simultaneity for granted. When something happens nearby, we assume we are aware of it as it happens. This assumption works because light crosses small distances quickly. The delay is too small to notice. But the stars dismantle this assumption gently but completely. There is no shared now across space. There are only overlapping pasts. Each star you see is a window into a different moment in time, and the sky is a collage of these moments layered together. Some of those moments are only a few years old. Others are decades old. Others stretch back centuries. The night sky is not a snapshot. It is a mosaic assembled from different eras. Consider what this means for even the nearest stars. When you look at one that is 4 light-years away, you are seeing light that began its journey when the world was subtly different. Technology may have advanced. Lives may have changed. Entire personal histories may have unfolded during the time that light traveled through empty space. And still, that light arrives quietly, indifferent to what happened after it left. The star does not know that time has passed. It does not know that civilizations rose or fell, that individuals were born or died. It simply shines, and its light moves on. This indifference is not cold. It is fundamental. The universe does not synchronize itself to us. We synchronize ourselves to the light that arrives. As we move beyond the very nearest stars, this effect becomes impossible to ignore. Stars tens of light years away appear as they were decades ago. Stars hundreds of light years away appear as they were when the world itself was in a different phase of its story. The light reaching you tonight from those stars began its journey before many of the structures you recognize existed, before cities expanded, before technologies emerged, before cultural moments you consider recent. This realization subtly alters the emotional texture of stargazing. The stars are no longer just distant suns. They are messengers from another time. They are carrying information forward through space, not knowing who will receive it or whether anyone will still be there when it arrives. Some of those messages arrive after their source has changed. Others arrive after their source has vanished entirely. This is where the idea of stellar ghosts enters quietly. A star you see may no longer exist in the form you see. It may have evolved, dimmed, flared, or died. And yet, its light continues, faithfully delivering an outdated image across the void. The universe is full of these delayed impressions, images of things that were, preserved by distance and speed. The near stars remind us that reality, as observed, is always slightly out of date. This does not mean that observation is false. It means it is incomplete. It is constrained by the rules of propagation. Light does not lie, but it arrives late. The concept of lateness becomes inseparable from truth at cosmic scales. Truth exists locally, where events happen. Observation exists elsewhere, arriving after time has passed. The greater the distance, the greater the separation between truth and awareness. Near stars sit at the edge of this realization. They are close enough to feel present, yet far enough to expose the delay. This tension creates a strange emotional effect. The stars feel intimate and remote at the same time. They are visible to the naked eye, yet fundamentally unreachable. They are part of our sky, yet isolated from our moment. As the distances increase, the past we are looking into grows deeper. A star several hundred light-years away appears as it did centuries ago. When that light left its source, the world was in a different historical era. the people alive today did not exist. Entire generations lived and died while that light traveled silently through space. This does not make the star ancient in itself. The star continues to exist, evolving on timescales far longer than human history. But our connection to it is ancient. We are not seeing its present. We are seeing a preserved slice of its past. This leads to a profound inversion of perspective. On Earth, we think of the past as something that fades, something that recedes and becomes inaccessible. In the universe, the past is everywhere. It surrounds us. It arrives continuously from all directions, encoded in light that has been traveling for years, centuries, or longer. The present, by contrast, is local. It exists only here, only now, only where you are. Everything else is delayed. The near stars teach us that the universe is not experienced as a synchronized whole. It is experienced as a collection of time-shifted views, each constrained by distance. This has subtle implications for how we think about change. On Earth, change feels immediate. We act, and consequences follow quickly. In space, change is slow to be known. A star can alter dramatically, and the universe will continue presenting its old image for years. The delay does not soften the change. It simply postpones awareness of it. This postponement creates a strange kind of stability. The night sky appears calm and unchanging because we are always seeing outdated information. The violence and transformation occurring elsewhere are hidden behind years of travel time. When a star eventually reaches the end of its life, the event may be sudden and catastrophic. But from our perspective, the sky remains unchanged until the final light arrives. The near stars are especially interesting in this regard because their delays are short enough to be relatable. A few years, a few decades, time spans that overlap with human memory. When you look at a star 10 light-years away, you're seeing it as it was 10 years ago. That is not an abstract span. That is a period you can remember. You can recall where you were, what you were doing, what the world felt like. And this creates a powerful connection. The star becomes a time capsule. Its light is a message sent from a moment you once inhabited. As distances increase further, this connection becomes more diffuse. Stars hundreds of light-years away appear as they were long before any living human memory. The light reaching us tonight left its source in a world that no one alive remembers. The farther you look, the more the universe becomes historical rather than personal. Yet even then, the principle remains the same. Light carries the past forward relentlessly. It does not care whether the recipient understands or remembers the context. It simply arrives. This continuity of arrival creates a steady flow of cosmic history into the present. The universe is constantly telling us what it used to be. Near stars occupy a special place in this flow because they sit at the boundary between memory and history. They are close enough that their delays overlap with human timescales, yet far enough to force us to confront the idea that we are never seeing the universe as it is. This realization has a quiet philosophical weight. It suggests that presence is always local, that what you experience as now is confined to your immediate surroundings. Everything else exists on a spectrum of delay. The near stars show us that this is not an abstract idea. It is a measurable reality. A star 4 light-years away is 4 years out of sync with you. A star 40 light-years away is 40 years out of sync. There is no way around this. No technology can remove the delay without violating the structure of space-time itself. The universe enforces patience. It enforces separation. It enforces the idea that knowledge arrives only after waiting. This has implications beyond astronomy. It subtly reshapes how we think about observation, information, and connection. We often imagine that if something exists, it can be known immediately. The stars remind us that existence and knowledge are not the same thing. Something can exist for years, centuries, or longer before its light reaches us, and by the time it does, the thing itself may have changed. Knowledge is always delayed. Awareness is always retrospective. The present, in a cosmic sense, is unobservable except locally. Near stars also challenge our sense of permanence. Because stars evolve slowly compared to human lifetimes, they appear stable. But this stability is an illusion reinforced by distance. Changes that do occur are masked by delay. A star may have already begun a transformation that we will not witness for decades, or it may have already completed one. The sky we see is not a live broadcast. It is an archive, updated continuously, but always late. This archive is vast, layered, and incomplete. It contains images of things that no longer exist and omits images of things that do. It is not wrong, it is simply constrained. The near stars, by their relative proximity, make this constraint tangible. They show us that even the closest cosmic neighbors are separated from us by years of waiting. And yet, there is something quietly comforting in this. The delay creates a buffer. It smooths out the violence of cosmic events. It allows the universe to appear calm and steady, even when it is not. The stars shine peacefully because we are seeing their peaceful pasts. The turbulence, the change, the endings are hidden behind time. This does not diminish their reality. It simply delays our awareness of it. In this way, the near stars teach us that distance is not just a measure of separation. It is a filter. It shapes what we see and when we see it. It determines which events arrive together and which remain isolated in time. The universe, as observed, is a carefully staggered procession of moments, each arriving according to how far it had to travel. This procession never stops. Photons leave their sources, travel through space, and eventually arrive somewhere. Some arrive at eyes. Some arrive at instruments. Some arrive where no one is listening at all. But they all carry the past forward. As we stand under the night sky and look at the nearest stars, we are participating in this procession. We are receiving messages that began their journey years ago, sent without intention, addressed to no one in particular. The fact that they arrive at all is a consequence of geometry, not purpose. And yet, when they arrive, they carry meaning. They tell us not just about the stars, but about the structure of the universe itself. They tell us that time and distance are inseparable, that observation is always delayed, that presence is local and isolation is fundamental. Near stars are not just points of light. They are demonstrations. They demonstrate that to look outward is to look backward, that the universe is built in such a way that the present is fragmented across space, that every direction you look reveals a different layer of the past. And as we prepare to move beyond near stars toward larger stellar neighborhoods and entire galaxies, this lesson will only intensify. The delays will grow longer, the past will deepen, and the realization that the universe is not a single moment, but a vast collection of delayed moments will become impossible to ignore. As the nearby stars taught us that looking outward is always looking backward, the galaxy takes that realization and expands it beyond anything that can feel personal. In Part 6, the delays introduced by near stars still overlapped with human memory. A few years, a few decades. Time spans that could be emotionally grasped, remembered, or imagined. The galaxy dissolves that intimacy. It moves us from the scale of personal history to the scale of collective existence. Here, the past we observe is no longer measured in lifetimes we can recall, but in epochs that shaped the conditions for humanity itself. The galaxy is where our sense of place truly begins to erode, not because it becomes confusing, but because it becomes overwhelmingly clear how small, how late, and how peripheral our presence really is. The Milky Way is not just a collection of stars. It is a structure, a rotating system bound together by gravity, stretching across distances so vast that even light requires tens of thousands of years to cross it. When we say we live in a galaxy, we often imagine a backdrop, a scenic context for the stars we see at night. But the galaxy is not scenery. It is the environment itself. It is the largest structure that still meaningfully contains us. And even within that structure, we occupy no special position. Our star is not near the center. It is not on the edge either. It resides in a quiet region, orbiting far from the galactic core, one star among hundreds of billions, moving along a path that takes so long to complete that entire civilizations rise and fall without ever noticing its progress. This orbit is not fast. It does not feel like motion, and yet it is constant. The Sun, carrying Earth and everything on it, is in continuous motion around the galaxy. This movement does not announce itself. There is no sensation of speed, no directional cue, no cosmic wind. From our perspective, the galaxy appears static, an unchanging pattern of stars. But this stillness is another illusion born of scale. The motion is real. It is simply too slow, and the distances too vast for the change to be perceived within a human lifetime. The galaxy introduces a new kind of time, a time so extended that individual lives disappear into it completely. When we speak of galactic timescales, we are no longer talking about years or centuries. We are talking about durations that encompass the entire story of our species many times over. This shift in scale has a profound effect on how the past behaves. In the realm of near stars, the past felt like a delayed version of something familiar. In the galaxy, the past becomes structural. Entire regions of the Milky Way appear as they were long before humanity existed. The light reaching us from distant parts of the galaxy began its journey when the Earth itself was in a very different state. Continents were arranged differently. Life was evolving along paths that would eventually lead to us, but not yet. And still, that light arrives now, quietly, blending into the band of stars we see stretching across the sky. The Milky Way, visible as a faint, hazy ribbon, is not a picture of the galaxy as it is. It is a composite of many different pasts layered together. Some stars appear almost current by cosmic standards. Others are ancient snapshots preserved by distance. The galaxy does not present a single moment. It presents a span of history compressed into a single view. This compression is what makes the galaxy so disorienting. On Earth, history unfolds in sequence. Past gives way to present. Present gives way to future. In the galaxy, these distinctions blur. The past surrounds us. It arrives continuously from all directions. The present exists only here, in the narrow region where light has not yet had time to introduce delay. Everything else is already history. The galaxy turns this into a permanent condition. It ensures that the universe we observe is never synchronized. There is no master clock ticking for all stars at once. Each region evolves according to its own local time, and we see each region only after its light has crossed the intervening space. This has subtle consequences for how we think about humanity's place. We often imagine ourselves as observers standing outside the universe, looking in. The galaxy reminds us that we are embedded within it, subject to the same delays and separations as everything else. Our observations are not privileged. They are constrained. When we look towards the galactic center, we are looking into a deep past shaped by intense gravitational forces, dense star formation, and dynamic processes that have been unfolding for millions of years. When we look outward toward the galaxy's outskirts, we see regions that are quieter, more diffuse, evolving more slowly. These differences are not just spatial, they are temporal. They reflect different stages of galactic evolution, revealed to us through delayed light. The galaxy, then, is not just a place. It is a timeline spread out across space. Moving inward or outward is like moving backward or forward through galactic history, though never perfectly. The relationship between distance and time becomes complex, layered, and non-linear. And yet, the underlying rule remains the same. Light takes time. Information arrives late. Awareness lags behind reality. Humanity's position within this structure is unremarkable in every physical sense. Our star does not occupy a central role. Our region of the galaxy is not particularly dense or energetic. We exist in a relatively calm zone, far from the turbulent core, far from the sparse extremes. This calmness may have been essential for life to develop. The galaxy is not uniformly hospitable. Some regions are violent, dominated by radiation, collisions, and instability. Others are too sparse to provide the heavy elements needed for planets. Our location appears to be a compromise, stable enough, enriched enough, quiet enough. But this suitability is not evidence of design. It is evidence of selection. We exist here because this is where existence was possible. The galaxy does not revolve around us. We revolve within it. This realization can feel diminishing at first. The idea that humanity is not central, not special, not even particularly noticeable on galactic scales can be unsettling. But there is another way to see it. The galaxy is not hostile to our insignificance. It is indifferent to it. And indifference, unlike hostility, allows for coexistence. The galaxy provides a vast stage on which countless processes unfold, most of them unaware of us, some of them indirectly responsible for our existence. The heavy elements in our bodies were forged in stars that lived and died long before the sun formed. Their explosions scattered material that later condensed into planets, oceans, and eventually life. In this sense, humanity is not separate from the galaxy. It is a product of it. Our atoms carry a galactic history. Our existence is a delayed consequence of events that occurred millions of years before Earth existed. The galaxy makes this lineage unavoidable. It forces us to acknowledge that our story did not begin here, or even with the sun, but with generations of stars spread across vast distances and deep time. The galaxy also reframes the concept of isolation. In Part 6, near stars felt isolated from us by years of waiting. In the galaxy, isolation becomes structural. Stars are separated by distances so large that interaction is rare. Most stars will never influence each other directly beyond the slow, collective pull of gravity. Communication, in any meaningful sense, is impractical. Signals weaken, delays grow, coordination becomes impossible. The galaxy is not a network of interacting neighbors. It is a loose congregation of largely independent systems, bound together by gravity but separated by emptiness. This has implications for how we think about life beyond Earth. The galaxy may contain countless stars, countless planets, countless opportunities for life. But separation ensures that even if life is common, contact may be rare. The galaxy does not encourage conversation. It enforces solitude. Each star system exists in its own temporal bubble, evolving according to local conditions, largely unaware of what is happening elsewhere. The galaxy's immense size guarantees this isolation. It is not a failure of intelligence or technology. It is a consequence of scale. Light takes too long. Space is too vast. The galaxy stretches the idea of community beyond usefulness. Humanity's place within this context is paradoxical. On the one hand, we are insignificant. One species on one planet orbiting one star in a galaxy of hundreds of billions. On the other hand, we are unique in at least one sense. We are aware. We can look at the galaxy and recognize our smallness. We can reconstruct its structure, trace its history, and place ourselves within it. This awareness does not make us central, but it does make us participants in a way that inert matter is not. The galaxy does not care that we understand it, but the fact that we can understand it at all is remarkable. The galaxy is vast, ancient, and largely indifferent, yet it has produced, in at least one small corner, a system capable of reflecting on its own insignificance. This reflection does not change the galaxy. It changes us. It invites a different relationship with scale. Instead of seeking importance through size or influence, we find it through perspective. The galaxy shows us that meaning does not come from being central. It comes from being aware. The Milky Way will continue its slow rotation whether we exist or not. Stars will be born and die. Regions will brighten and fade. Entire eras will pass unnoticed by any observer. And yet, for a brief moment, in one small region, awareness has emerged. The galaxy is not built for us, but it contains us. And that containment is enough. Looking at the galaxy, we are not looking at a destination or a future home. We are looking at the context that made us possible. We are looking at a structure so vast that it dwarfs individual lives, yet so coherent that it can give rise to complexity and awareness. The galaxy is not our backdrop. It is our origin. And as we prepare to look beyond it, toward even larger structures, this realization becomes essential. Because if the galaxy already dissolves our sense of centrality, what lies beyond will dissolve even our sense of belonging. As the galaxy revealed humanity's place as local, peripheral, and temporary, it also hinted at a deeper boundary, one that no amount of motion, patience, or technological ambition can cross. In Part 7, the Milky Way became the largest structure that still felt like an environment, a vast but coherent system in which our story unfolded quietly at the edges. Beyond it, however, the universe stops behaving like a place you can belong to at all. It becomes something stranger, something defined not by what exists everywhere, but by what can ever be known. This is where the idea of the observable universe emerges, not as a region we inhabit, but as a limit imposed by light itself. The observable universe is not the entire universe. It is the portion of the universe whose light has had enough time to reach us since the beginning of cosmic history. This distinction matters deeply because it means that reality extends beyond what we can ever see, measure, or interact with. The universe does not end at the edge of observation. Our knowledge does. The observable universe is a horizon, not a wall. It is a boundary created by time, not by space. To understand this boundary, we need to combine everything we have learned so far. Distance has become delay. Delay has become history. Light has become the courier that carries the past forward. And now, at the largest scale, light becomes the gatekeeper of existence itself. The observable universe is defined by a simple condition. Light must have had enough time to travel from an event to us. If it has not, that event is, for us, indistinguishable from non-existence. This does not mean the event did not happen. It means it happened outside our causal reach. The universe may be far larger than what we observe. It may even be infinite. But infinity is not something light can traverse in a finite time. And so, the observable universe is not a measure of how big the universe is, but of how old it is. The farther we look, the earlier we see. Eventually, we reach a point where looking farther back becomes impossible, not because space ends, but because time does. Light cannot carry information from before light itself could move freely through space. This creates a natural observational boundary. Beyond it, the universe is opaque, silent, unreachable. The observable universe is shaped like a sphere around us, but this shape is deceptive. It does not imply centrality. Every observer, anywhere in the universe, would see their own observable universe centered on themselves. This is not because they are special, but because light has only had so much time to travel since the universe began. Each location has its own horizon. There is no universal vantage point. There is no place where the whole universe can be seen at once. This alone is a profound limitation. It tells us that the universe does not offer a complete picture to any observer, no matter how advanced. Knowledge is always partial. Perspective is always local. As we push outward toward this horizon, the delays we encountered with stars and galaxies stretch into unimaginable spans. We are no longer looking back decades, centuries, or even millions of years. We are looking back billions of years to epochs when the universe itself was younger, denser, and radically different from what we experience now. Galaxies appear smaller, closer together, more chaotic. The structure of the cosmos changes as we move deeper into the past. This is not because the universe is changing with distance. It is because we are seeing different stages of its evolution layered across space. The observable universe is therefore not a static container. It is a time gradient. Nearby regions appear older, more evolved. Distant regions appear younger, closer to the universe's beginning. At the edge of observation, we approach the earliest moments when light could travel freely at all. Before that, the universe was opaque, filled with energy and particles so dense that light could not move without constant interaction. Beyond that point, there is no image to receive, no light to capture. The universe becomes invisible, not because it vanishes, but because it has not yet made itself observable. This is the ultimate consequence of the finite speed of light. Not only does it delay information, it permanently hides vast regions of reality. There are parts of the universe whose light will never reach us, no matter how long we wait. The expansion of space itself ensures this. As the universe expands, distant regions recede faster and faster. Beyond a certain distance, space stretches away more quickly than light can cross it. Light emitted there today will never arrive here. It is not late. It is lost. This introduces a new and unsettling concept. There are events that will never be known, not because we lack technology, but because the universe forbids the connection. The observable universe is not just a snapshot of the past. It is a shrinking window of relevance. Over time, fewer and fewer regions remain observable. Galaxies drift beyond the horizon, their light stretched and dimmed until it fades entirely. The universe becomes quieter, not because it empties, but because separation increases. This silence is not temporary. It is permanent. The limits of light impose a limit on memory itself. The universe does not preserve all of its history for all observers. History becomes fragmented, local, incomplete. Each region carries its own record, and much of it is inaccessible elsewhere. The observable universe also reshapes the idea of existence. We are accustomed to thinking that if something exists, it exists absolutely. But at cosmic scales, existence becomes conditional. Something can exist beyond the observable universe and still have no influence, no presence, no consequence for us. Its existence is real, but irrelevant. It might as well not exist from our perspective. This does not diminish its reality. It reveals the relational nature of knowledge. To exist for an observer, something must be causally connected. Light must have time to arrive. Without that connection, existence remains abstract. The observable universe defines the boundary of causal relevance. Inside it, events can matter to us, at least in principle. Outside it, they cannot. This boundary is not something we cross to reach. It is something that surrounds us inherently. No journey can take us beyond it. Moving faster does not help. Waiting longer does not help. The horizon moves with us. It is not a place in space. It is a condition of time. This has profound implications for humanity's place in the cosmos. In the galaxy, we were peripheral but embedded. In the observable universe, we are isolated within a bubble of knowability. Everything we will ever observe, measure, or influence lies within this finite region. The universe may be far larger, but our story is confined to this sphere of light. This does not make the observable universe small. It is unimaginably vast, but it is finite in a way that the universe itself may not be, and finitude changes how we relate to it. It introduces boundaries not of exploration, but of understanding. We can never see the universe as a whole. We can never know its full extent. We can infer, model, and speculate, but direct observation stops here. The limits of light enforce humility. They remind us that there are questions that cannot be answered empirically, not because they are meaningless, but because they lie beyond causal reach. The universe allows us to see enough to understand that we are not central, not eternal, not complete. But it does not allow us to see everything. This is not cruelty, it is structure. The observable universe is the compromise between total ignorance and total knowledge. It gives us a vast, detailed, dynamic picture of reality, while permanently withholding its entirety. As we look out toward this horizon, we are not approaching the edge of space. We are approaching the edge of time. We are seeing the youngest light, the earliest structures, the first moments when the universe became transparent enough to reveal itself. Beyond that, there is no image, no signal, no story we can receive. The universe becomes silent, not because it stops existing, but because light cannot bring it to us. And so, the observable universe is not a destination. It is a reminder that everything we know is mediated by light, that knowledge arrives late, that reality is larger than perception, and that our place within the cosmos is defined not by how far we can go, but by how much the universe allows us to see. As the observable universe revealed the limits of what light can ever bring to us, it also exposed a deeper and more unsettling boundary. In Part 8, we reach the horizon where knowledge itself runs out, where space does not end, but visibility does. Beyond that horizon, existence may continue endlessly, yet remain forever disconnected from us. Within that vast but finite bubble of light, however, there remains a question that feels impossible to ignore. If the observable universe contains hundreds of billions of galaxies, each with hundreds of billions of stars, and if planets appear to be common rather than rare, then where is everyone? This question does not arise from speculation alone. It arises from silence, a silence so persistent and so complete that it demands explanation. This is the heart of what is known as the Fermi paradox. The paradox is not a formal theory. It is a tension between expectation and observation. On one side lies scale. The observable universe is enormous, ancient, and filled with environments where life could, in principle, arise. On the other side lies experience. We look out into the cosmos and hear nothing. No signals, no unmistakable signs of technology, no evidence of civilization spreading across stars or galaxies. The universe, as far as we can tell, is quiet. This silence becomes more striking when viewed through the lens of everything we have already explored. Light connects events across vast distances, but it also imposes delay and limits. The observable universe is large, but it is not infinite. It contains a staggering number of stars that have existed for billions of years, far longer than humanity. If intelligent life were common, if technological civilizations arose frequently and endured, then some trace of their activity should have reached us by now. Light would have carried it. Signals would have crossed the void. Artifacts of large-scale engineering would have left imprints on the cosmos. And yet, the sky remains unchanged. The stars shine as stars. Galaxies behave as galaxies. There is no obvious signature of widespread intelligence. The paradox emerges from this contrast. It is not asking whether life exists elsewhere. It is asking why the universe appears so empty of communication. Why, in a universe where time and space are vast, does the observable region feel so devoid of voices? One possibility is that the silence is an illusion created by distance and delay. Civilizations may exist, but they may be too far away, their signals still traveling, their light not yet arrived. Given the scale of the observable universe, this is plausible. Signals take time. Perhaps we are simply early. Perhaps the universe is still young in terms of intelligence, and we are among the first to emerge. In this view, the silence is temporary. It is a matter of timing. But this explanation becomes less satisfying when we consider the age of the universe. Billions of years have passed since the first stars formed. Entire galaxies matured long before the sun existed. If intelligent life were common and long-lived, it would have had ample time to spread, to signal, to leave detectable traces. The silence persists across distances where light has already had time to arrive. This suggests that distance alone may not be enough to explain it. Another possibility is that life itself is rare. The conditions required for life, especially complex technological life, may be extraordinarily specific. While planets may be common, planets that develop stable environments, chemistry conducive to life, and sufficient time for intelligence to emerge may be uncommon. In this view, the silence reflects scarcity. The universe may be full of stars, but poor in minds. Humanity may be an outlier, not because it is special, but because the path that led to it is narrow. This possibility is sobering. It suggests that the universe is not teeming with civilizations waiting to be discovered, but largely indifferent, with intelligence appearing only rarely and briefly. The silence, in this case, is not imposed by distance, but by improbability. A third possibility is more unsettling. Intelligent civilizations may arise, but they may not last. The same processes that allow intelligence to develop may also lead to its destruction. Technological capability brings power, and power brings risk. Civilizations may destroy themselves through conflict, environmental collapse, or unintended consequences of their own creations. If this is common, then the universe may briefly host intelligent life, but rarely for long enough for it to spread or communicate across interstellar distances. The silence would then be a graveyard silence, not of absence, but of impermanence. The sky would appear quiet because voices rise and fall faster than light can carry them far. Another explanation focuses not on rarity or fragility, but on choice. Advanced civilizations may choose not to broadcast. They may recognize the risks of exposure or simply lose interest in outward communication. They may turn inward, focusing on local concerns, virtual realities, or modes of existence that leave no detectable imprint on the cosmos. In this scenario, the universe could be full of intelligence, yet appear silent because intelligence does not announce itself. The absence of signals would not imply absence of minds, only absence of broadcasting. There is also the possibility that we are not listening correctly. Our assumptions about communication may be deeply human. We look for signals that resemble our own technologies, transmitted in ways we can recognize. But intelligence elsewhere may communicate differently, using methods or channels that do not intersect with our instruments. The silence may reflect a mismatch between expectation and reality. The universe may be speaking, but not in a language we understand. Each of these possibilities carries its own implications, but they all share a common foundation. The universe is large, and light enforces separation. Communication across cosmic distances is difficult, slow, and fragile. Even if civilizations exist, even if they attempt to communicate, their signals weaken with distance, blend into noise, or arrive long after their source has changed. The observable universe does not guarantee connectivity. It guarantees isolation. The Fermi paradox emerges not because the universe should be loud, but because it could be, and yet it is not. This silence takes on a different character when viewed alongside the limits of observation. In Part 8, we saw that large regions of the universe are permanently inaccessible. Events there can never influence us. It is entirely possible that civilizations exist beyond our observable horizon, forever hidden by the expansion of space. Their signals will never reach us, no matter how long we wait. In that case, the silence we experience is not representative of the universe as a whole. It is representative of our bubble of causality. We are listening within a finite region, and that region may simply be empty of other minds. The paradox, then, is local rather than universal. It reflects the conditions of our cosmic neighborhood, not the entire cosmos. The silence also forces a shift in perspective. It invites us to consider that intelligence may not be a dominant feature of the universe. Stars, galaxies, and cosmic structures evolve according to physical laws indifferent to awareness. Intelligence may be an emergent phenomenon, rare and fleeting, not something the universe is designed to produce abundantly. In this view, the silence is not mysterious. It is expected. The universe is not empty of meaning, but meaning is not distributed evenly. It arises in pockets, briefly, and then fades. Humanity may be one such pocket. This realization can feel isolating, but it can also feel clarifying. If the universe is silent, then our experience of meaning does not depend on external validation. We do not need a chorus of cosmic voices to justify our existence. The silence becomes a backdrop against which awareness stands out more sharply. The Fermi paradox also reshapes how we think about time. Civilizations may exist, but not at the same time. The universe is old. Civilizations could rise and fall, separated by millions of years, never overlapping, never knowing of each other's existence. Light would preserve traces of their pasts, but those traces might be too faint, too brief, or too subtle to detect. The silence, in this case, is temporal misalignment. Minds exist, but not together. The universe is not synchronized for intelligence any more than it is synchronized for stars. This idea aligns with everything we have learned about delay and isolation. Time separates just as effectively as space. The Fermi paradox, then, is not a single question with a single answer. It is a reflection of scale. It emerges when human expectations collide with cosmic reality. We expect that a large universe should be busy, populated, communicative. The universe responds with distance, delay, and silence. That silence does not tell us exactly why it exists. It tells us that connection is not guaranteed, that awareness is local, that intelligence, if it arises, does so within constraints that may prevent it from ever being known elsewhere. And so, the silence becomes part of the universe's character. It is not a void to be filled, but a condition to be understood. The stars do not speak because the universe does not require them to. Light moves, carrying information where it can, but it does not ensure reception. The observable universe is vast, but it is fragmented into isolated regions, each with its own history, its own possibilities, its own silences. Humanity exists within one such region, looking outward, listening, and finding only the quiet persistence of stars. This quiet does not negate wonder, it deepens it. It suggests that the universe is not a conversation, but a landscape. A landscape where awareness arises occasionally, briefly, and without guarantee of companionship. In this landscape, the silence is not empty. It is full of distance, full of time, full of things that exist beyond reach. The Fermi paradox does not tell us whether we are alone. It tells us that if others exist, the universe has made it very hard for us to know. As the silence of the cosmos settles around us, the question is no longer where everyone is, but how we are meant to live with the quiet. In Part 9, the Fermi paradox did not resolve into an answer so much as it dissolved into perspective. The universe, vast and ancient, offers no assurance of companionship. Light travels faithfully, yet messages rarely arrive. Civilizations may be rare, fleeting, distant, or simply unreachable. Whatever the reason, the silence remains. And now, at the end of this journey, we are left not with conclusions about the universe, but with reflections about ourselves. Because the final impact of cosmic scale is not scientific, it is emotional. It forces a reckoning with meaning, isolation, and comfort in a reality that does not revolve around us. At first, this reckoning can feel unsettling. The universe is enormous. Time is deep. Humanity occupies a narrow slice of space and an even narrower slice of history. We are not central. We are not ancient. We are not guaranteed continuation. The stars do not notice us. The galaxies do not respond. And yet, this very indifference contains a strange form of relief. When nothing is watching, nothing is judging. When the universe does not demand significance, significance becomes something we are free to define. This is the beginning of what might be called a comfort paradox. A comfort found not despite cosmic insignificance, but because of it. Throughout this exploration, we have seen that distance becomes time, time becomes history, and history becomes layered into everything we observe. The universe is not immediate, it is patient. Light moves at its unyielding speed, carrying stories forward without urgency. Stars live and die on timescales that make human concerns seem fleeting. And yet, within this immensity, awareness has emerged. Briefly, locally, quietly. The fact that we can reflect on our own smallness is not something the universe owes us. It is something that has happened against overwhelming odds in one small region. This does not make us important in a cosmic sense. It makes us rare in a contextual sense, and rarity does not require grandeur to be meaningful. Meaning does not scale with size. A moment does not become more meaningful because it is observed by a galaxy rather than a single mind. A life does not become more valuable because it echoes across light years. Value, as experienced, is local. It exists where awareness exists. The universe may be silent, but silence does not erase experience. It frames it. In a universe filled with noise, voices compete. In a universe filled with silence, even a single voice matters to itself. The comfort paradox lies here. When we stop expecting the universe to respond, we stop needing its validation. The absence of cosmic witnesses does not diminish love, curiosity, or wonder. It allows them to exist without performance. We do not have to matter to the universe to matter to each other. The stars do not need to listen for conversations to be worth having. In fact, the silence grants privacy on the largest possible scale. Our thoughts, struggles, and joys unfold unnoticed by anything beyond our immediate surroundings. There is no cosmic scoreboard, no universal judgment, just existence, experienced briefly and then passed on. This perspective softens the weight of impermanence. We have seen that everything we observe is already the past. The universe preserves history in light, but not indefinitely. Horizons advance, regions fade, signals weaken. Even galaxies drift beyond reach. Nothing lasts forever, not even memory on cosmic scales. At first, this seems tragic. But consider the alternative. A universe that preserved everything forever would be overwhelming. It would trap all moments, all errors, all pain in permanent display. The fading imposed by distance and expansion allows forgetting. It allows release. It ensures that no moment, however intense, dominates eternity. Transience becomes a kind of mercy. In this light, the silence of the universe is not neglect. It is spaciousness. It creates room for finite stories to exist without being swallowed by infinite consequence. Humanity's story does not need to echo forever to be complete. It needs only to be lived fully where it occurs. The stars we see are ancient messages, but they do not ask us to reply. They simply arrive, reminding us that the universe continues regardless of attention. This can feel lonely, but it can also feel stabilizing. When the universe does not care, failure is not cosmic. When the universe does not watch, mistakes are not eternal. We are free to exist imperfectly. We are free to explore meaning without needing it to be universal. The comfort paradox is not about denying insignificance. It is about accepting it and discovering that acceptance brings calm rather than despair. The universe is not hostile. It is not benevolent. It is indifferent. And indifference, unlike hostility, leaves room for gentleness. There is no cosmic urgency demanding that we rush or conquer or dominate. The vast scales of time reveal that there is no deadline imposed by the universe. There is only the time we experience. Within that time, attention becomes precious. Moments become valuable, not because they are rare in the universe, but because they are rare to us. Each experience is a brief alignment of awareness and existence. The fact that this alignment is temporary gives it texture. It sharpens it. If everything lasted forever, nothing would feel distinct. The silence of the universe also reframes solitude. Being alone on a cosmic scale does not mean being alone in experience. Connection does not require abundance. It requires presence. Two minds sharing a moment generate more meaning than a billion stars burning in isolation. The universe may be empty of voices, but it is not empty of processes that gave rise to us. Every atom in our bodies passed through stars. Every breath connects us to cosmic history. We are not outsiders looking in. We are expressions of the same laws that govern galaxies and light. The difference is not in substance, but in awareness. The universe is what happens when matter follows rules. We are what happens when matter notices itself, briefly. That noticing does not have to be loud. It does not have to travel far. It does not have to last. Its value lies in the fact that it occurs at all. And so, when we return from this journey through distance, delay, silence, and scale, we are not returning with answers. We are returning with orientation. We know now that the universe is vast beyond intuition, that light limits connection, that history surrounds us, and that silence is not an anomaly, but a feature. We also know that within this framework, comfort does not come from centrality or permanence. It comes from alignment. From understanding where we are and what the universe is not asking us to be. The cosmos does not require conquest. It does not demand explanation for existence. It simply unfolds. We are free to do the same, in our own way, on our own scale. As you lie here, letting these thoughts drift, consider that the universe will continue its slow expansion regardless of whether you understand it. Stars will shine. Light will travel. Horizons will recede. And within this vast, indifferent motion, your awareness exists now. That is enough. Not because it matters to the universe, but because it matters to you. The comfort paradox is that in accepting how small and quiet our place is, we are released from the burden of cosmic significance and allowed to rest in simple existence. The universe does not promise meaning. It offers space. And in that space, meaning can be whatever gently fits.